Okay, welcome to video 11.2. Today we're going to be talking about the roots and zeros of quadratic equations, and these are things that we've actually already talked about, so it should be a review topic for you. So the zeros, roots, or what we also call the x-intercepts, are where the parabola crosses the x-axis. Since these points are on the x-axis, the y value is always equal to 0. And again, this is something that we've already talked about. The next part says we want to write a quadratic equation that has these zeros, -5 and 8. Well, remember we talked about this before, and this is kind of like working backwards. If we know that the x value is -5, that's the root. That's where it crosses the x-axis. And it crosses again at 8. Well, what do those come from? Those come from when it was actually equal to 0. So if I wanted to get this one on the left, x equals -5 equal to 0, I'm going to add 5 to both sides. And that'll make the 0 on the right-hand side here, and then we'll have x plus 5 on the other. So x plus 5 is the factor where we got that x equals -5. And then we'll do the same thing with x equals 8. To get it equal to 0, we'll subtract 8 from both sides. And then we get this x minus 8 equals 0. Now those come from the factors, so now I can write these as being multiplied by each other. But it's not an equation yet because equations need equal signs, so I just need to write y equals. So now we have an equation, but we might also want to simplify it, especially if it was a multiple choice answer, or if they said it needed to be in simplest standard form, which would mean we would need to multiply and have it from highest exponent to lowest exponent. So to do that, we would want to use the area model. So the x plus 5 is on the top and the x minus 8 is on the side. Go ahead and pause the video and give that a try before moving forward. I have x squared plus 5x minus 8x minus 40. And I have like terms on the diagonal that show up here for the 5x and the minus 8x, so I'm going to put those together. And then when I combine those, I end up with y equals x squared minus 3x minus 40. So either one of these is correct. I just wanted to show how that could be simplified. And then I just put a box showing that either one is acceptable. Okay, let's look at the next one. Number 2 first asks, what are the roots of the parabola on the grid? So let's identify those first. So remember, those are the points where it crosses the x-axis. So I identified them on the graph with points. Now I just need to write down what they are. So I can see that they happen at an x value of 6 and an x value of 8. So I will write those two down. The next part says write an equation for this graph. Well, if I know that these are the roots, how can I work backwards to then find out what the factors are that these roots came from, and then furthermore simplify it to write this quadratic in standard form? Pause the video and see if you can answer that question before moving forward. So I need to make it equal to 0. Right now it's equal to 6. So to make this 6 become 0, I'm going to subtract 6. If I subtract 6 on this side, I must also do it on the left side. So subtract 6 from both sides. So then I have x minus 6 equals 0. So where does that come from? Well, we set the factors equal to 0. So now I'm just going to write the x minus 6 in parentheses to show that it is one of the factors. Now try doing the other side on your own and pause the video to give yourself time. So to do this one, we're going to subtract 8 from both sides, and then we end up with x minus 8 equals 0. Now that's another one of my factors, so next to the x minus 6 in parentheses, I'm going to write the x minus 8 in parentheses to show that those are the two factors. And then the next question is this an equation? Well, no. Normally we have y equals, and it definitely needs an equal sign in order to be an equation. Now we want this to be in standard form, so we need to do something else. Can you think of what that is? Pause the video and try on your own. So in order to simplify, we need to do the area model to show the binomial times the binomial. So x minus 6 times x minus 8, and then fill in each of the cells. When we do that, we get x times x, x squared, negative 6 times x is negative 6x, negative 8 times x is negative 8x, and negative 6 times negative 8 is positive 48. Now we look for any like terms. Usually they show up in the diagonal as they do here, so I have a negative 6x and a negative 8x that can be put together. So then I write this as y equals x squared minus 14x plus 48. But now we need to do an important thing. We need to check this in our calculator to see what we get when we look at this graph. So in y equals, plug in x squared minus 14x plus 48. Next, look at the graph yourself and see if your graph matches the graph on this picture. Does it? Well, the answer should be no, because this graph is a positive a value, a positive x squared. That means that it would be a happy face parabola or opening upward. This one is negative or opening downward. So how can I make this negative? Well, we can multiply by a -1. But if we multiply this by a -1, we must distribute it to all three of the terms. So then we get y equals -x squared plus 14x minus 48. And if I put that in my calculator, the graph would match. So you can go ahead and try that. Okay, for number 3, it says, what are the roots of the parabola on the grid? So go ahead and give that a try, and then write an equation for the graph. So you're going to try this one on your own. Pause the video to give yourself enough time. Okay, so hopefully you got the answer of y equals x squared minus 2x minus 3. Where did that answer come from? Well, the roots, first, I went to the graph and I saw that it crossed the x-axis at an x value of -1 and an x value of 3. So I started by writing x equals -1 and x equals 3. Then I added 1 to both sides to end up with the x plus 1 equals 0, and then subtracted 3 from both sides to get the x minus 3 equals 0. And that was so that I knew what the two factors were that made these answers. So then I got y equals x plus 1 times the x minus 3. From there, I wrote out an area model to show that since it's a binomial times a binomial, I need to make sure that I multiply all the terms. And then I had the x squared plus 1x minus 3x and then minus 3. Then combined like terms to end up with y equals x squared minus 2x minus 3. Next, I want to go to my calculator to check, and that's really important because if you have a parabola that's a smiley face parabola and your equation is not matching, you'll see it when you try to graph. I can see that this is a smiley face and so is this one, so I am good with my answer. The ones that can get a little tricky are the frowny face because we need to remember to distribute the -1 like we did in the previous example here. For number 4, if the roots of a quadratic equation are -2 and 3, the equation can be written as, well, we have a couple options. One would be to look at all these options and solve to find what the x values actually are, but I think the easier way is to do what we were just doing in the previous example, which is to start with what the roots are and work backwards. So now we need these to be equal to 0 instead of x equals -2, so I'm going to add 2 to both sides. So then I get x plus 2 equals 0. Then I need to do the same thing on the other side with the x equals 3. Now looking at my options, choice number 2 matches that answer with x plus 2 and x minus 3. Okay, for number 5 here, we need to solve for the zeros of the equation y equals 2x squared minus 16x plus 30. So we have 3 options to solve for zeros. First, I'm going to rewrite 0 equals instead of y equals, and then we'll talk about the 3 options. First option is to use the quadratic formula. We could also complete the square or use factoring. For this one, I'm going to show quadratic formula because the a value is bigger than 1, so completing the square I would need to divide first. Secondly, if I try to factor, I see a GCF here, so I just know it's going to be more than one step for factoring. So to use the quadratic formula, start off by having your reference sheet next to you so you can look at the formula. Then identify the a, b, and c value. The a value is 2, b is -16, and c is 30. Next, with your formula next to you, just fill in all of the variables with the values in this question using parentheses. Once we've done that, and pause the video to make sure that yours matches mine, we can simplify the numbers. So -16 becomes 16. Plus minus, and then all of the information that's under the square root, but not the square root yet, will go into the calculator to find out what the new number under the square root is. When we do that, we get 16, but it's still under a radical. And then in the denominator, 2 times 2 is 4. Now I can take the square root of 16, so in the next step, we're going to change the square root of 16 to 4. So x equals 16 plus minus 4 divided by 4. This is really two different answers. Those answers are 16 plus 4 divided by 4 and 16 minus 4 divided by 4. Now you can either put these in your calculator if you know how to insert fractions, or you can do the numerator, clean that up first, and then divide by the denominator, or put the numerator all in parentheses and then divide it by 4. Either way, you'll get the same answer. So 16 plus 4, that's 20, and then 20 divided by 4 is 5. So x equals 5. The next one, 16 minus 4 is 12. 12 divided by 4 is 3, so x equals 3. Remember, you can just circle those answers, or you can write it in set notation saying that the two answers are 3 and 5. Okay, number 6 here says find the x-intercepts of y equals x squared minus 2x. Remember, x-intercepts, zeros, those mean the same thing. Just set it equal to 0. The y value is 0 if it's crossing the x-axis. Okay, so my options are the same. I can either use completing the square, factoring, or quadratic formula. This time I'm going to model factoring. So the first thing we always look for when we factor is a GCF. Here I can see that there is a GCF. It's x. So I'm going to put the x squared minus 2x in a box and factor out that greatest common factor. So when I factor out the GCF, which would be an x out front, then you ask yourself, what times x would give me x squared? That would be an x. And then what times x would give me a negative 2x? That would be a negative 2. So now I have my two factors, x and x minus 2. So I started off with the 0 equals x squared minus 2x, and now it's 0 equals x times x minus 2. Now I always look to see if I can factor further. So this is a difference, but these are not both perfect squares. So that tells me this is factored as far as it can be. So now I can set up my t-chart and solve for each one. If either of these two factors is 0, the product would be 0. So I need to set the factors equal to 0. So x equals 0 and then x minus 2 equals 0. Well, to solve for x on the right-hand side, I need to add 2 to both sides. And then I get my answer, x equals 2. On the left side, x equals 0. When I set that one equal to 0, I was solving for it as well, since it's already equal to 0. So those are my two answers, which again, you can either just circle or write in set notation. Okay, number 7 says, what are the coordinates of the turning point of the parabola whose equation is y equals x squared minus 4x plus 4? Well, the key word here is the turning point. In order to find the turning point, I need to first find the axis of symmetry, since that divides the parabola in half and therefore finds where the turning point occurs, or when it happens on the x-axis. So in order to find the axis of symmetry, I need to sub into the formula. So start by writing the formula and then identify the a and b value. A equals 1, b equals negative 4. Now go ahead and pause the video. Try subbing in and finding the axis of symmetry. The axis of symmetry is x equals 2, the vertical line that cuts the parabola in half. Now, remember to sub in a negative 4 over 2 times 1. That becomes 4 over 2, which becomes the 2 value. Now that I have the x, I know that it's not 2 or 4, but I'm still between 1 and 3. So in order to find the y value, we need to take the x value that we just found and plug it into the equation. Remember to use parentheses whenever you sub in a value, so you should have the 2 everywhere we used to have an x. If you have done that with parentheses, you can put it in the calculator exactly the way that it is shown, and it'll give you the output. So in went 2, out came y, 0. So my point is 2, 0, choice 1. We could also check that in our calculator by going to y equals, plugging in the equation, and then looking at the table of values. Okay, the next question says that a student correctly graphed the parabola shown below. Using this graph, answer the questions below. The first one says find the zeros of the graph. Well, zeros, that just means the x-intercepts, or where this graph crosses the x-axis right here. So where does it cross the x-axis?
I drew them on the graph with those blue dots. So if you count then to see where it crosses the x-axis, it's at an x value of 2 and an x value of 5. The next question says we need to write an equation that represents this graph. Well, we're going to do this in the same way that we've done for the previous examples. So pause and give it a try to see if you can write the equation.
Okay, so working from the roots, I have x equals 2 and x equals 5. But in order to work backwards, these come from the factor. So I need it equal to 0 since we set the factors equal to 0. So for the x equals 2, to work backwards, we subtract 2 from both sides. That'll end up having it 0. So x minus 2 is the factor. So that's where this x minus 2 came from. And then on the right, we subtract 5 from both sides to get x minus 5. And that comes from the factor x minus 5. Now we're not done yet because we can simplify this by multiplying the binomials together. So we use an area model to do that. So x minus 2 and then the x minus 5. X times x gives me x squared. Negative 2 times x gives me a negative 2x. Negative 5 times x gives me a negative 5x. And then negative 5 times negative 2 gives me positive 10. Then we look for like terms. Usually they show up on the diagonal as they do here. Negative 2x minus 5x is negative 7x. So my answer is y equals x squared minus 7x plus 10. The last thing I need to check for is we can look at the picture by putting this into y equals to make sure that this is a smiley face graph just like what we wanted here, and it is. Okay, that's it for this one. Homework for tonight is to do homework 2. Have a good night.